Hello everyone, welcome. This video is going to be about scaling databases. Okay, so consider this particular database server and you have certain amount of data present on this server. Okay, now if your database starts growing, so as soon as your application or your system becomes popular, your database will start growing. Okay, so as soon as it starts growing, what is the first solution that comes to your mind, be it any kind of database? The first solution would be increasing capacity of your database server, right? Increasing capacity means increasing RAM, increasing storage, or increasing compute power of your database server. Okay, but in this particular kind of increase, after a certain point of time you won't be able to increase the capacity. There is the maximum supported capacity of this particular database server, right? So at max, let's say it supports only 32 GBs of RAM. It cannot support beyond that. So you will not be able to increase RAM beyond this capacity. Let's say it supports only uh, 10 TB of storage. So it will not be able to support beyond this capacity, right? But your database size is still increasing. As your database size increases, there would be a point in time where a single database server will not be able to keep all the database. Okay? Or it will not be able to accommodate the complete database. So what is the solution? Eventually you will have to split your database and you will have to store it on multiple servers, right? Because one single server cannot keep all your data. Okay? So what you will do, this is your database. You will split your database into partitions, into multiple partitions, and these partitions are called as shards. Okay? And now each of these shards would be present on separate database servers. So this is how you will eventually solve the problem. Now, when you have multiple shards and when you need to perform read or write on your database, how will you perform? Let's say this is database about some students and you need to fetch data about student with roll number, let's say 123. So how will you know that on which database server this student data is present? How will you know? In order to solve this problem, we introduce a hashing mechanism. Okay. To understand this particular thing, consider this particular case. Let's say that all the students who appeared for JEE mains, their scores are to be stored on a database server. Okay? And single database server is not enough for this, so we have multiple database servers. Okay? Now in order to know which student's data is present on which server, we'll introduce a hash function. Okay? Now here let's say we have 3 servers, so n becomes 3. Okay? And let's say uh, for simplicity we have assumed that 6 students have appeared for JEE mains exam. Originally you can assume 6 lakhs students, right? For simplicity we are assuming 6 students have appeared for JEE mains school. Now the number of keys is going to be 6. Now let's say you need to identify or you need to write data about student with student ID 3 on a database server. How will you write? So in order to identify which database server to use, you will take the key that is student id, and you will take student id and you will perform mod with respect to 3. What do you get? You get 0, right? So student id with id 3 will be stored on server number 0. Okay. Let's do this for all students. So student with student id 1, where will it go? 1 mod 3 gives us 1. So student with student id 1 goes here, his data goes here. Student with student id 2, where will it go? 2 mod 3 gives us 2, so it will go here. Student with student id 3 will go on database server 0, so student 3 will go here. Similarly, 4 mod 3 gives us 1, 5 mod 3 gives us 2, and 6 mod 3 gives us 0. So fourth student details would be stored here, fifth student details would be stored here, and sixth student details would be stored here. Okay? This is how we read or write, we can read or write data when we have multiple database servers, or we have partitioned our database, right? Now there could be some problems associated with this kind of implementation. What would that problems be? Now let's assume that one of your database server has gone down. So let's assume server number 2 has gone down, and no one can reach that server. So what will happen? The number of servers now reduces to 2. So in this case, see, all the students want to know their marks. So how do you solve this problem? You will have to repartition all your data. So now what will happen? Instead of 3 servers, you have 2 servers. So all the keys would be repartitioned. So now the new data would be 1 mod 2 gives 1, 2 mod 2 gives 0, 3 mod 2 would give 1, 4 mod 2 would give 0, 5 mod 2 would give 1, 6 mod 2 would give 0. Okay? So now this was the data for n is equals to 3. Now when you have 2 servers, what happened? The data of student 1, 3 and 5 goes here, and data of student 2, 4 and 6 will go here. Okay? So now what did you observe from this? Almost all the keys have to be moved to a new server, right? 3 was present on server number 0, but now it has moved to server number 1. Okay? And 4 was present on server number 1, but it has now moved to server number 0. Apart from this, both these keys have to be moved onto a new server. So out of 6 keys, you have to move, you have moved 4 keys, right? So almost all the keys have to be moved. If you see, like more than 50% of the keys you have moved on to a new server. Okay? So this is the problem number 1, this particular scheme. Whenever a new server is added, or a server goes down, you will have to move the keys, or you will have to do the resharding or repartitioning thing. Okay? That is one particular problem. This is problem number 1. What is problem number 2? Now let's suppose this is not for This database is not JEE mains course. This database is about, this is a social media database, and all these database servers contains data about users. Okay, so in that case, uh, if a database server gets profile of Virat Kohli is the, so as far as I know, Virat Kohli is the most followed person in India. Let's say next is Shraddha Kapoor. Okay, so let's say 4 or 5 of these very famous personalities, all those personalities data is sharded or is hashed on to same server, and all other common people like you and me, their data is sharded onto server number 1. So what will happen? The number of reads and writes on server number 0 would be very high, very high. So server number 0 would be loaded way more than server number 1, right? So this is known as celebrity problem. It could happen that one particular server will get very large number of reads and writes. So this should not be the case. The number of reads and writes, the partitioning should be such that the number reads and writes requests should also be redirected uniformly onto the server. Okay. Third is, the third problem is joins. We know that in relational databases we perform normalization. What is normalization? We split our tables into smaller tables, right, to reduce redundancy, right? But in case when your table is present on multiple servers, you cannot perform join operation very efficiently. Okay, there would be various problems, like you have referential integrity constraints. So let's say there is a table with some foreign key. Okay, you have primary key and you have foreign key here. Okay, and this particular table is present on this server, but you have another table and you have primary key here, and the foreign key from this particular table is referring to primary key of this particular table, but this table is present on server number 1. In that case, how will you check the referential integrity constraints? Okay, this is one more problem. So joining and referential integrity constraints would pose a severe problem in case of relational databases. So there could be two solutions. All your tables should be denormalized. Denormalize all your tables and store them on the database servers. This could be one solution, or another solution could be you can move to non-relational databases. Okay, so these are the problems associated with database sharding. I hope you would have understood this. Thank you.